Hello Bearcats. This lesson we will discuss types of variation. How to enter data in your calculator and use the regression features we will discuss in class. The types of variation we will review are direct, inverse, and joint variation. Let's give you some specifics about direct. This is a review from last year. You will see it written several ways. You might see it most commonly written as y varies directly as x, or y is directly proportional to x. And the formula for direct variation are y equals kx. There can be things going on with x as well, so it could be squared or cubed or something. So you might also see it written as y equals kx and then just to an n, to a number. K is a constant and often needs to be determined from given data. So K is our constant. And that's true in all our variation. Okay, for inverse variation, you would see maybe y varies inversely as x, or y is inversely proportional to x. All right, and the formula for that, or the equation, not formula, but the equation for that is y equals k over x. K over x. I almost think direct is directly next to, and inverse is inverted or underneath. All these equations start out with y equals k. Y equals k. K again is still the constant. All right, for joint variation, you might have y varies jointly as x, and z. And it could be several things, more than two. You would have y is jointly proportional to x and z. And again, it could be several things. The formula most often, or the equation most often written would be y equals k. Notice they all start with y equals k, and you could say x and z. All right, so joint is almost like it's direct, but just more things join in on your little party there. All right, let's look at 3 examples, and then I will leave you to it. First example, read this problem here. Neglecting the air resistance, so ignoring air resistance, the distance an object falls varies directly. Okay, so the distance, I'm going to circle the things that are important, varies directly as the square of the duration, and they're going to call the duration the time t. So let's just write it up as a regular. It's direct, so you know it's right next to. They all start with y equals kx. Let's plug in. So the distance, the first variable mentioned in your problem is your y, so the distance, so d, we're going to call that d for distance. D equals k. It varies directly as the square of t, so t squared. So we rewrote it using the correct variables. The next thing we're going to do first is find k. So the first step, first step is to write it. The second step is to find k with given information. It says an object falls a distance of 140 feet in 3 seconds. Let's find k. So it falls a distance, so the distance is 144 equals k in 3 seconds, but we have to square that. So that's 144 equals k, or not, times 9, and we would divide both sides by 9, and k would be equal to 16. 144 divided by 9 is 16, so that is our k. The equation of variation would be written this way. Y equals our k value of 16x, and in this case, well, squared, or really in this problem we should have written distance equals 16t squared. This would be your equation of variation. Your equation of variation. Notice how much that looks like a quadratic in this case. So That is your equation of variation. Let's go on to the next example. The next example says a company found that the demand for its products, so the demand for its products varies inversely as the price. Okay, so demand varies inversely as the price. So we would have y equals inverse would be k over x. And in this case, this is our y. So demand is equal to k over n price. And this is what our equation would look like at the beginning. When the price is $2.75, the demand is $600. We want the equation of variation. So we have to find k. So this is step 1. Step 2, find k. So to find k, I'm going to say the price is $2.75. So $2.75. We don't know what k is. When the demand is 600 units. So you could put that over 1 and cross multiply, and you would have k equals 600 times 275. And in this case, k is equal to 1650. 1650. So our equation of variation would be written as, we're going to go by our original one, but now we have a value for k. So we would have our demand is equal to 1650 over our price. And that 1650 is a constant. All right, now what I want you to do is I want you to use your equation that you found, and I want you to predict what the demand would be when the price is $3.25. Okay. If you think about it, you would think that if the price goes up, the demand would go down a little bit because it would be more expensive and it would go down a little bit. But let's see what happens. So we're going to use this formula and we're going to plug in our price of $3.25 and figure out our demand. So our demand is going to be equal to $16.50 divided by $3.25, which is going to be approximately 508 units, just as we expected, a little less than when it was only $2.75. All right, last example. The volume of an enclosed gas, okay, so the volume, be careful about what you're reading. It's not the gas itself, but its volume varies directly as the temperature, okay? Uh-oh, and there's a big thing there. And so two things are going to be going on inversely as the pressure. So volume is V, temperature we'll use T, and pressure, temperature we're going to use K for Kelvin. And pressure is going to be in cubic centimeters, but we're going to call it P. So we got a couple things going on. So we're always going to say our first is like, this is like our Y value. So we're going to start with V equals K always. Now directly means next to temperature, which we're going to say, we're going to call this T because, I'm going to change that. We're going to call this T because K, we're using K as our constant, so we'll call this T. So K times the temperature, and then inversely, which would be underneath, divided by the pressure. And that's how we would set up the problem. Now let's look at what we have. We want to find the pressure when the temperature is 300 and the volume is 7,000. But we don't have our equation of variation first. We need to find our equation. So first, we're going to substitute in what we know. Given, this is the given stuff. You always plug in the given to find your equation of variation. Then you can find something using the equation. Given that the pressure is 0.75, when the temperature is 294, and the volume is 800. All right, so we would go through here. You can cross multiply, so you're going to get K times 294 equals 800 times 0.75, and then to solve for K, you would divide everything by 294. So you would find your K, your constant, to be approximately 1,000 over 49. I don't want to round any decimals in these problems because it could cause a real issue with a real life problem. So I'm just going to leave it in the improper fraction. Now I'm going to write my equation of variation, which is our step 2. So this is our equation of variation. Actually, this is step 3 because step 2 was finding our K. Okay, so we found our K. Now we're going to write the equation of variation. Our equation of variation, we're going to go back to this, but we're going to plug in for K. So we're going to say our volume is equal to, and then I'm going to put a parentheses, 1,000 over 49 times RT all over P. That's the equation we want to use. Now, what did we want to find out? This is what we wanted to find out. We want to find the pressure, so we're not going to know our P value. We have our constant. When the temperature is 300, so times 300, and the volume is 7,000. You might want to think about this for a minute. Let's see. The pressure was 0.75 when you had a low volume and a medium temperature, 294 temperature, that's high, 294 temperature. The temperature changed a little, but the volume went way up. Do we think that would cause our pressure to be greater or smaller? I would think it would be a little larger, but let's check it out. I'm going to put this over 1 and cross multiply. So I'm going to get 7,000 times the pressure equals 1 times, and that's just the 1,000 over 49 times the 300. And to solve for P, I divide all that by 7,000. I always like to set that up first before I put it in my calculator. When I do, I'm going to get the pressure is approximately 0.87. And pressure was, look at the units, was kilograms per centimeter squared. All right, that's it. Look forward to your warm-up tomorrow. Go Bearcats!